Right now, you probably feel like you're sitting completely still. The environment around you is quiet, and it takes the slightest ripple in a cup of coffee to make you notice any physical vibration in the room at all. But this 3D model tracking our planet's axis tells a different story. If you look right here at the equator, the surface of the Earth is violently whipping around at roughly 10,670 kilometers an hour. We exist on a rock traveling at extreme speeds, yet if you stand up and spin in a tight circle for just 5 seconds, your inner ear will struggle to keep your balance. How is it that we can stand on a massive sphere tearing through the vacuum of space and feel absolutely zero physical movement? Our physical senses are lying to us. To understand the environment we actually live in, we have to look past human biology and rely on the physics governing the ride. Human biology detects motion by looking for external visual changes. We require a clear reference point to know we are moving. When you sit on a moving train, you know you are traveling fast because you can look out the window and watch the city blur past. Earth operates like a train with no windows. Our entire atmosphere, the buildings, the trees, and everything else around us travels at the exact same rotational speed. We also possess a major biological blind spot when it comes to feeling speed. The human nervous system cannot detect constant velocity. It is only equipped to sense sudden changes, moments of acceleration or deceleration. Think about riding in a commercial airliner cruising at 1,000 kilometers per hour. With the window shades pulled down, the cabin feels perfectly still. Your body only registers the sudden thrust of takeoff and the heavy braking of landing. The planet's rotation works exactly the same way. The spin is perfectly uniform and relentless. There is no cosmic gas pedal and no sudden braking to trigger a physical reaction. As long as an environment maintains a constant velocity and deprives us of external visual cues, our brain cannot tell the difference between extreme speed and an absolute standstill. But a constant speed and a lack of visual cues do not account for the physical mechanics of a spinning object, which naturally generates a force pushing outward. This is centrifugal force. You experience it on a playground carousel. As the ride spins faster, you feel a distinct pressure pulling your body outward, away from the center. Given Earth's massive rotational speed, that outward push theoretically exists right now. The math dictates it should be strong enough to hurl objects and people straight off the crust and into space. We stay firmly planted because that outward push runs into a dominant opposing force, Earth's gravity. This data model visualizes the clash at the equator. The tiny outward vector of centrifugal force is completely overpowered by the massive inward vector of gravity, which is 300 times stronger. That advantage crushes the outward push, locking everything to the crust. The sheer strength of the planet's gravity acts as an unbreakable physical anchor. It pins us down with such overwhelming force that we forget we are on a ride at all. Our daily rotation on a single axis is only a fraction of our actual movement. This scale model of the solar system tracks our broader trajectory. We are simultaneously hurtling along our orbital path around the Sun at a speed exceeding 107,200 kilometers per hour. We are tearing through a void on a spinning rock at compounding, incomprehensible velocities, yet we sit comfortably in our chairs, convinced the room is motionless. Our biological senses were engineered by evolution to solve local problems. They detect the sudden movement of a predator or the speed of a falling object. They were never built to process our macro position in the wider universe. The comforting quiet we experience every day is a biological illusion. It is a necessary evolutionary shield, filtering out the high-speed chaos of the cosmos so we can simply focus on surviving on the surface.